Hello students, welcome to classroom. In today's class, we will be learning about types of chemical reaction. So there are four types of chemical reactions which you have to study. They are combination reaction, displacement reaction, and double displacement. So we have to study these four types of chemical reaction. So let us start the class by discussing each of them one by one. So types of chemical reaction, the first one is combination reaction. The second one is decomposition reaction. The third one is displacement reaction. And the fourth one is double displacement. Currently it's thundering. Double displacement reaction. During change of season, the onset of every season, it is always accompanied by rain. So there has been a slight shower, and so in the background you may be hearing some thunder sounds. Now let us start the first one. So combination reaction. So combination reaction. So what is combination reaction? Let us understand this together. So those chemical reaction or combination reaction is a type of chemical reaction in which two or more substances join to give a product. So let us write the definition. So combination reaction is a chemical reaction in which, so a chemical reaction in which two or, let me use another marker, in which two or more substances join to give a product. So we have a product, so that means we have reactants also. So which are the reactants here? Well, these substances are the reactants. Okay, so these are the reactants. So when I say in the definition two or more substances means the reactants. Remember, in every chemical reaction we need to have reactants. Okay, it's only when we have reactants we get a product. Always remember that. So a chemical reaction in which two or more substances join to give a product. Now let us discuss some examples from the textbook. So I have your textbook here with me. So there are some examples here. We can always have a look at burning of coal is one example given on page 7. So example, burning of coal is an example of combination reaction. Burning of coal. Okay, coal is a fossil fuel. Okay, remember that coal is a fossil fuel, and we are running out of fossil fuels, so we have to use fossil fuels judiciously. So carbon plus oxygen gives carbon dioxide. This is an example which is mentioned in your textbook. I'm just copying down from the textbook. So this is an example of combination reaction. How so? Let us understand this. See, we have two substances here, two reactants here, carbon and oxygen. So carbon and oxygen, they undergo a chemical reaction, and what are we getting? We're getting a product, carbon dioxide. So this is an example of combination reaction in which two or more substances join, they undergo chemical reaction, and they give us a product. So this is the product. So this is the product. This is the product, and these are the reactants. All right, simple, nah? Now let us discuss another example. So another example, so let us take another example again. So CaO, okay, calcium oxide plus water. Now this example is again mentioned in your textbook. So CaO plus water, it gives us CaOH2 plus heat. Now there's a reason why I'm discussing this chemical reaction. The reason why I'm discussing this chemical reaction is because of this. Okay, this is very important. Okay, now see, if you observe this chemical reaction, you have the reactants, okay, calcium oxide and water. So calcium oxide reacts with water. What do we get? We get calcium hydroxide, okay, which is also known as slag lime. Slag lime is calcium oxide mixed with water, okay, slag lime, okay. Then heat. Do you see this? Pay attention to this. In this chemical reaction, we get heat, okay. So this chemical reaction releases heat, okay. There are some chemical reactions which proceed by releasing heat. Such type of chemical reactions are known as exothermic reactions. So when we discuss combination reaction, you should also know about exothermic reactions, okay, because it is discussed under this topic only. So now let us write what exothermic reactions are. So exothermic chemical reaction, exothermic reaction. So exothermic reaction. What is an exothermic reaction? Let us write the definition of exothermic reaction. So chemical reactions which move forward by releasing heat, okay, are known as exothermic chemical reaction. See, this chemical reaction, this reaction proceeds. This reaction is happening, and as the reaction happens, heat is released. Yes or no? So such type of chemical reactions are known as exothermic chemical reaction. So exothermic reaction. So chemical reaction, write down the definition. Chemical reactions which proceed by releasing, okay, heat are known as exothermic reaction. All right, so chemical reactions which proceed by releasing heat are known as exothermic reaction. Now we will go to the next topic. We'll discuss the second point, which is decomposition reaction. So let me make some space here. So let's discuss the second one. Make sure that you're making notes. You can always pause the video and make notes, okay. It is always healthy. It is always good to have notes. Next point, we'll be discussing about decomposition reaction. Decomposition reaction. So let us learn what decomposition reaction is. Decomposition reaction, we can say, is the exact opposite of combination reaction. Now, what is the definition of decomposition reaction? So chemical reactions in which a single reactant breaks into two or more product, okay, two or more substance, two or more product are known as, or is known as, decomposition reaction. Decomposition, you know the meaning of the word decomposition, okay, breaking down, okay, breaking down. So decomposition reaction, chemical reaction in which a single reactant breaks into two or more substances or two or more products. Let's write substances, okay, is known as, or are known as, let's write R, okay, are known as decomposition reaction. Decomposition reaction. All right, so what is a decomposition reaction? Chemical reaction in which a single reactant breaks into two or more substances are known as decomposition reaction. Example. Now, what example has been mentioned in your textbook? It is good to refer to your textbook. So yes, so yes, let us take this example. F example, okay, FeSO4, okay, it breaks down to give Fe2O3 Fe2O3 plus SO2 plus SO3 SO2 plus SO3. Yes, so see, a single reactant, okay, a single reactant breaks down to give, okay, two or more substances. Okay, if you find that this example is very complex, then we can always go and take a simple example like CaCO3. CaCO3, this is, then it breaks to give you CaO plus COT, CaO plus CO2. Okay, so this is calcium carbonate. Okay, calcium carbonate breaks down to give you calcium oxide plus carbon dioxide. All right, got it. This is more easier than this one. Okay, this is calcium carbonate, CaCO3. Calcium carbonate breaks down, okay, undergoes decomposition reaction and gives calcium oxide, CaO, calcium oxide. CO2 is a gas. You are all familiar with CO2. Okay, we breathe out carbon dioxide. So this is an example of decomposition reaction. Now, decomposition reactions are also decomposition reaction. As they proceed, as a reaction proceeds, they absorb heat. Okay, they absorb heat. Decomposition reactions, as they proceed, they absorb heat. Such type of chemical reactions are known as endothermic chemical reactions. So there is a question in the textbook maybe. Okay, endothermic reaction. What do you mean by endothermic reaction? So let us write about endothermic reaction, because endothermic reactions are discussed under decomposition reaction. So endothermic reactions. So write down endothermic reactions. Endothermic reactions. What is an endothermic reaction? Reactions, chemical reactions which proceed by absorbing, by eating heat, okay, are known as endothermic reactions. So write down chemical reactions which proceed by absorbing, okay, by absorbing. Don't write eating in the answer, but you write by absorbing heat, are known as endothermic reaction. Okay, so chemical reactions which proceed by absorbing heat are known as endothermic reaction. Here I want to give you a simple example which will help you remember endothermic reaction. Okay, example, melting of ice. Okay, how does ice melt? Okay, ice melts by absorbing heat energy, isn't it? You take the ice out of the freezer and then keep it, okay, keep it in your hand. What happens? It will absorb heat energy from your hands and it will start melting. It will start undergoing a change in state from solid to liquid. Okay, so a simple example is melting of ice. Such type of chemical reactions, okay, which proceed by absorbing heat, okay, by absorbing heat, are known as endothermic chemical reactions. All right, so now we will go to the third one, which is displacement reaction. I hope you are all following. Now we go to the third displacement reaction. Displacement reaction. Very, very important, okay? Very, very important. This displacement reaction is very important. Okay, displacement reaction and double displacement reaction are important. Okay, so please please pay attention and listen. So displacement reaction. What is a displacement reaction? So displacement reaction is a type of chemical reaction in which takes place between an element and a compound, okay, in which the element goes and displacement, okay, in which a more reactive element goes and displaces the least reactive element. Okay, so displacement reaction is a type of chemical reaction which takes place between an element and a compound, okay, in which the more reactive element displaces a less reactive element from the compound. All right, so let us write this displacement reaction. A chemical reaction in which a more reactive element displaces a less reactive element from a compound. Okay, we can also add one more sentence here. Okay, at the very beginning we can add like displacement reaction takes place between an element and a compound. Okay, remember that displacement reaction takes place between an element and a compound, and in the next double displacement reaction it will be taking place between two compounds. So this is also one difference between displacement and double displacement. Okay, of course the word double is also the one difference, but then between displacement and double displacement, simple displacement, this is also known as simple displacement because it takes place between an element and a compound. Okay, for example, let us have a look at your textbook. So we have one example. Let me take one example from the textbook. We have iron plus CuSO4. CuSO4. Okay. Now, please, I want you all, okay, to pay attention because this is very easy. Now, the reaction will take place. Okay. Now, how will the reaction be? Okay. How will the reaction be? Okay. So, what will be the products here? Now, see here. Here, okay, by observing the element, this is the element, okay, like I said, displacement reaction takes place between an element and a compound. So this is the element, okay, and this is the compound. Okay, now a chemical reaction in which a more reactive element displaces a less reactive element from a compound. Now see here, displacement will take place. Do you know what is displacement? Displacement means like it's like chasing away, okay, like displacing. You have to you have to move away. Okay, replacement is like replacement. Okay, so displacement reaction. Now here iron is more reactive than copper. Okay, now metal, iron is a metal, copper is also a metal, but iron is more reactive than copper. Now you may ask like, well sir, how do we know that, or how do we know that iron is more reactive than copper? That's a good question. Then we have to, okay, then I have to tell you about something here which is called the reactivity series. So it is there in your textbook. Okay, it is there in your textbook. So there is this reactivity series, which is an arrangement of metals based on their reactivity. Means based on their reactivity. So you have to know that. You have to know the reactivity series. Okay, it is only after you know the reactivity series you will be able to know, okay, that iron is more reactive than copper. I know because I know the reactivity series. So now you have to know, okay, you have to know. In class 10 the reactivity series is very important. So it is there in your textbook, but we can also, I can write now here. So it is an arrangement of elements based on their reactivity. Okay, so okay, I'll just write down here. So we have potassium, we have sodium, we have calcium, we have magnesium, we have what is the next element here? Aluminium, we have carbon, okay, then we have, okay, I'll just write it here, okay, zinc, then we have iron, then we have lead, then we have hydrogen, then we have copper, then we have mercury, then we have silver, then we have gold. See, these are the metals which are found in the reactivity series. Okay, we start from potassium, okay, making potassium the most reactive element. Okay, so there will be two arrows. Okay, you can always study like this, so you can do like this. Okay, or you can go like this. Oh, my arrow. Okay, so like this. So the most reactive element is potassium, okay, and the least reactive metal is gold. Okay, so as you go down, the reactivity decreases. This is called the reactivity series. Okay, this is called the reactivity series. So as you go down, what happens here? Reactivity decreases. So remember here, reactivity decreases. So I should write down reactivity decreases. So reactivity decreases. Reactivity decreases. Okay, reactivity decreases, and here reactivity increases. So it's difficult to write. Okay, just let me write for like this. So reactivity, okay, it's getting messier. Okay, it's getting messier. So let me just write here. Reactivity increases. Okay, so as you climb up from the bottom to the up, the reactivity increases, which means between gold and silver, silver is more reactive. Between copper and lead, lead is more reactive. Between aluminum and magnesium, magnesium is more reactive. Okay, because as you climb up from the bottom to the top, the reactivity keeps on increasing. Okay, so between sodium and potassium, so potassium is more reactive because as we go down as you climb up, the reactivity becomes more. The reactivity keeps on increasing. Okay, it keeps on increasing, increasing. Finally, we have potassium, the most reactive metal. Similarly, okay, as you step down, the reactivity decreases. So you are here. If you step down to put sodium, now your reactivity has decreased. Sodium is less reactive than potassium. Similarly, magnesium is less reactive than calcium. Similarly, carbon is less reactive than magnesium. Okay. Similarly, iron is less reactive than zinc. Iron is less reactive than aluminum. Okay. Similarly, copper is less reactive than lead. Copper is less reactive than iron. Okay. So this reactivity series is very, very important. It is only after you know the reactivity series that you will be able to solve this displacement reaction. So you have to know this reactivity series. Okay, and then there is a quick way to know this. Okay, to know this, I'll tell you how to write this when we do metals and non-metals. Okay, so likewise, okay, if with the trick, it's so easy. Okay, so even me mentally I have used that mnemonics to do this. So I will teach you that very soon. So now iron, where is iron? Here is iron. Okay, here is iron. And then copper, where is copper? Copper is here. So copper is here. Now tell me which is more reactive. Copper is more reactive or iron is more reactive? Now follow. Okay, see, you are here, this is iron, this is copper. Now if we look at the order, we find that iron, okay, if we go down, okay, if we go down, we encounter iron first. Okay, now the ranking of iron is also higher here. Okay, we can say the potassium is rank 1, 2, 3, 4, 5, 6, 7, 8. So the rank of iron is 8, whereas the ranking of copper is 9, 10, 11. So who will be more reactive? Definitely 8 is more reactive, isn't it? So iron is more reactive than copper. Thereby, iron can displace copper. A more reactive element can displace a less reactive metal. Okay, so what will happen here? Iron will displace copper. Iron will displace copper. Reason? Because iron is more reactive than copper. Okay, so now we know what will happen. Now, what will happen? Iron will displace copper. Means copper will be removed. Copper will be removed. So copper has to let go of. Copper will be removed from here. So this, okay, this position, copper will no longer be allowed to occupy this position. Okay, instead iron will come and occupy this position. Okay, so iron will come and occupy this position. So who is not moving? This fellow is not moving. So we can always write the one who is not moving first. Okay, now we know that iron will displace copper, so iron will be found here. Okay, now when iron displaces copper, this space is left behind, isn't it? This space is left behind. So who will come here? Copper has to come here. Okay, copper has to come and take the place vacated by iron. So now copper will be found here. Okay, so this is how displacement reaction works. Okay, it's very easy, but you need to know this. Okay, without the knowledge of reactivity series, it is very difficult. It will be not easy to do this. I hope it's all right. So please study this. Okay, please know this. Okay, once you know this, this becomes very easy. So here, in this chemical reaction, a more reactive element displaces a less reactive element. Okay, remember that. So iron being more reactive has displaced copper. Okay, since copper is less reactive than iron, copper cannot defeat iron. So iron can defeat copper. So iron wins, iron displaces copper. Okay, now we go to the next one, which is double displacement. So double displacement and displacement, they are almost similar. Okay, they are almost similar. And in double displacement also we need this table, so I will not be erasing this table. Okay, I'll just keep this table here. So I'll be keeping this table. All right, so now we go to double displacement, the fourth point. Double displacement. Double displacement reaction. So what is double displacement reaction? Okay, chemical reaction which takes place between two compounds in which an element from one compound will displace another less reactive element from the other compound. Okay, confusing, huh? It's okay, all the confusion will be cleared. Okay, the definition, okay, may sound very complicated now, but once you understand, okay, it will be very easy. So first let's write down the definition. So double displacement reaction, a chemical reaction between two compounds. Remember, in displacement reaction it was between an element and a compound. In double displacement it is between two compounds. A chemical reaction between two compounds in which a more reactive element from one compound displaces a less reactive element from the other compound. All right, so a chemical reaction between two compounds in which a more reactive element displaces one compound, in which a more reactive element from one compound displaces a less reactive element from the other compound. Okay, so everything, all the confusion will be cleared. Let us just take one example, and one example is enough for you. Okay, I promise you. Okay, you will understand with one example. So let us have a look at the example mentioned in your textbook, page 11. So Na2SO4. So Na2SO4. SO4 plus BaCl2. BaCl2. And then this is what we will be discussing. Okay, I will not write the product because that is what we should be learning together. So now look at the reactants. These are the reactants. Okay, now see, this is a product, this is a compound, this is a compound. This is double displacement reaction. Double displacement reaction. Okay, in double displacement reaction, the double displacement reaction takes place between two compounds. Okay, this is a compound, this is a compound. So there are two compounds here. Now, in which a more reactive element from one compound displaces a less reactive element from the other compound. So now I want you to pay attention and look at these two compounds. Okay, now here pay attention to the metals. Okay, metals. Got it? Do not pay attention to these things. Okay, do not pay attention to these things. Pay attention to the metal. Pay attention to the metal. Now this is identified as sodium. Do we have sodium here in the reactivity series? Yes, we have. We have here. So let us make an arrow here. Now let us forget about this one. Let us remove this thing. Okay, so we have sodium there, and barium. Okay, barium is not there, but if I'm not mistaken, I think barium is between somewhere here. It may be either here or here. Okay, it may be either here or here. Okay, so it is either between sodium and calcium or between calcium and magnesium. Okay, so it may be here or it may be here. Okay, remember this. So barium will be either here or here. Okay, now suppose barium is here. If barium is here, then still it is below sodium, isn't it? So who is more reactive? Sodium is more reactive because barium is below sodium. Okay, below sodium means he is less reactive than sodium. Okay, so elements which are down, okay, in the reactivity series, they are less reactive. Elements which are found, okay, higher in the reactivity series, they are more reactive. So sodium is here and barium may be here or barium may be here, but in both the cases it is below sodium. So sodium is more reactive than barium. That means sodium can displace barium. So sodium can displace barium. So what will sodium do? Sodium will displace barium. Okay, sodium will displace barium. Now, so displacement will take place. Okay, sodium will displace barium. Now, which are not moving? This and these two, okay, they are not affected. Okay, so the ones which are not affected, we will write them first. So we can write SO4 first here. SO4 we can write here. Even this is there. Cl2 is also there. Okay, Cl2 also there. Now I'm writing them first because they are not affected. Okay, they don't move. Displacement reaction will take place between metal and metal only. Okay, it's between who is more reactive and who is less reactive. So sodium is more reactive. So sodium will displace barium. So sodium will be found here. That means sodium will go here. Now this is where sodium will be. Okay, and then since sodium has gone here, this place becomes empty. Okay, this place becomes empty. Now previously there was barium here. Now he doesn't have a place to go, so he will come and occupy the place vacated by sodium. So now barium will be seen here, which means it will be seen with SO4. So barium will be seen here. Okay, and that's it. This is how double displacement reaction works. So see, it is a chemical reaction which takes place between two compounds. It is between these two compounds in which a more reactive element, the more reactive element here refers to sodium, okay, from one compound, which is from this compound, displaces a less reactive element, displaces barium, okay, displaces barium, which is found in the other compound. Okay, this type of chemical reaction is known as double displacement reaction. So are we clear? It's not difficult, isn't it? Okay, so we will end the class from here today. In the next class we will learn more again. So continue watching and continue to learn. Thank you.